Alright guys, today I want to talk about my LED display module. It's pretty thin. It's actually, the whole system is only 7 blocks deep from the front panel all the way to the back of the module itself, which I thought was pretty narrow. It's like your 7 bar calculator display type system. And what I really want to point out is how exactly the piston tape and everything is operating and what's triggering the lights. So you can see these blocks, this whole wall is getting pushed up, pushed over, pushed back down, and this is 20 rows of blocks. So it's like 20 lines of code, so to speak. And let me turn it off and kind of show you what's going on here. Okay, so we got this thin piston tape moving around, and in between here we have furnaces every once in a while with wood inside. And these comparators, see, that can suck a signal through a block, and it's detecting the wood and it's powering up this light down here. The next time these pistons get pushed up, it'll go to a glass, and when it's on a glass, if I have one, it doesn't see the furnace, so it doesn't turn on the bar of lights. The way the tape is clocked or cycling, when this row gets pushed up, this observer sees it and it fires this row of pistons. When this row gets pushed down, this observer sees it and it fires the top row of pistons. When this top row of blocks gets pushed across, this observer sees that, hard charges this block, which gives us a signal down to this repeater and fires our bottom row of pistons back in front of the first observer. Now this observer sees this row move over, fires this wall, and the cycle starts over. It's pretty smooth. It's got some issues with the fact that the comparators turn off slower than they turn on. They turn on instantly. There's a tick before they turn off, so the light kind of lags behind when it's running, and I'm trying to smooth that out. I have been working on a setup where I'm trying to get this even 1 block thinner, so from the display to the back it'll only be 6 blocks deep instead of the 7. Not that it really matters, I just like to make things as slim as possible. But yeah, let me fire it back up and take another look at it in operation. Okay, so now we're running. And another thing I want to point out is, like, this bar is controlled by the column coming up and down on this side. This bar is controlled by the column right behind it. This one is controlled by the column to the right of it. The center one is from the center column, and this one's getting information from this column. And so we're using, the tape is actually as wide as what the brown concrete is back here to control this display. Then you can build these and link them together. I have them where the bottom is just a T flip-flop, and it goes to another module that just has the observer facing the T flip-flop, and it fires this row, cycles it around 1 time. So every time this gets to a 0, it will fire off the next module and it will count up. Now the thing is, I'm playing this on Xbox360, so the tick speeds from observers and stuff are different on different systems, and sometimes the output needs a repeater and sometimes it doesn't. And if you mess up the timing too much, it breaks really easy because this is a even number of piston tape blocks, so there's only 2 gaps at a time. Whereas some of the bigger systems, you have an odd number, so there's 3 gaps and 1 filled spot, and they don't usually break, they just stop, so they're easier to fix. Here's some other projects that I started working on, and maybe possibly in the future I might make a video on exactly how to build this, because it's not too bad, it's not as complicated as it looks, and it goes up pretty quick. But if you enjoyed it, hit the like and stay tuned. Thanks, guys.